Hi everyone, welcome to my channel. My name is Manuel, and today we are going to talk about my phase project for the Machine Learning Engineering Postgraduate Program at FIAP. This time we focus on improving our model, introducing a LSTM neural network for asset prediction. So we are going to talk about how we improve our model accuracy from 59% to 91%, and we also reduce our overfitting by 95%. So let's get started. First of all, we are going to see everything working. I have a Docker environment here with all our dependencies, the model API, the data lake API, and our web system to interact with the model. And here is our model API Swagger, where we have all our endpoints documented. And here we can start complete pipeline training. Let me execute this. And we can see the logs on our container. So the training will start. And when it's done, we can do some predictions. Apart from the logs, we are also using ML flow for observability and monitoring our trainings. We can see on a SQL database or experiments. Here is the pattern that we are using to the name of each one. And here is an example of the metrics that we record on each execution. After each complete training request, we can see in the files of our container on the app folder, ML runs folder that contains artifacts generated for each execution. The model itself, and also a dashboard file. Let me open for us, where we can see actual samples by ticker. We have our labels here, the actual price, the predicted price, buy, sell, and hold signals that were predicted for the model during the evaluation of the training. After we have our neural network trained, we can do some predictions using our web system, and the model give us a predicted action and a predicted price for the given asset. So let me show you how our LSTM model works. We feed our model with sequence of 32 time steps. This means we look at the last 32 days of data to make a prediction. Uh, our LSTM layer has 64 hidden units. This is where the model learns the temporal patterns. And after the LSTM, we apply a dropout with a rate of 0.4, and this helps prevent overfitting by randomly turning off some neurons during training. Then we have two heads of representation, one for classification that outputs buy, sell, and hold, and another one for regression that outputs the price return. Now, talking a little about our final performance, we could achieve some key improvements, 95% reduction in overfitting, a 54% improvement in classification accuracy, 99.8% R2X score for regression. This is an excellent price prediction. And we could achieve this because how we train our model. We used a combined loss function. We multiply the classification loss by 20 and the regression loss by 50. This way, both tasks contribute to the learning process. For classification, you use something called focal loss. This helps us deal with class imbalance because we have way more cell signals than buy or hold signals. We set the gamma parameter to 3, which makes the model more careful when predicting minority classes. And we also use several regularization techniques to prevent overfitting on the regression head. So we have a dropout at zero point 0.4 with decay, gradient clipping, and early stopping. So to conclude, we successfully improved our model from 59% to 91% accuracy. We reduced overfitting by 95%. We achieved 99.8% R2 for regression. Our model still have some problems with class imbalance, but it's stable and production ready. And that's all for this one. I hope you all enjoy. I will leave the links for the GitHub repository and the technical documentation in the description. And see you in the next one.